Thank you so much to the organisers of the Test of Time Award for honouring Alan Jeffrey and myself for our paper Authenticity by Typing for Security Protocols, which was published at CSF way back in 2001. I say that on behalf of Alan as well as myself. Alan is not well at present and sends his regards. I'm truly sorry that neither of us can attend. Alan and I were students at Edinburgh University in the 1980s. Our very first lecture in computer science was given by Robin Milner. Robin was a hero to us, and Robin also supervised Alan's final year project on CCS. Our paths diverged as graduate students. Alan went to Oxford to study concurrency theory, whereas I came to Cambridge to study functional programming. Meanwhile, back in Edinburgh, Robin was inventing the pi calculus, a theory of communicating processes that was published in 1992 in collaboration with Paro and with Walker. And I think a key contribution of the pi calculus is its really elegant algebraic treatment of fresh names. So in 1995, I began a collaboration with Martin Abadi on what we called the SPI calculus. The idea was to model cryptographic security protocols within the pi calculus, and we made use of the fresh name operator in the pi calculus to model fresh generation of names and keys in security protocols. So security protocols, as you may well know, are hard to get right. There's subtle things that can go wrong with them. So our hope with the SPI calculus was to provide a formalism for reasoning about security protocols and even proving them correct. The good news was we could do that, but it was a hugely laborious manual effort. So 5 years later, in 2000, Alan and I took a different approach, and we found a new way to construct invariants for processes in SPI. We invented a type and effect system for the SPI calculus, and it could prove that one event preceded another. And so this could capture the usages of fresh keys and nonces, and we could capture those as typing rules. And Alan invented and built a system called Cryptic, the cryptographic protocol type checker that was based on our type system. By inventing suitable types, we checked a standard suite of symmetric key protocols, and in the process we rediscovered some known bugs and discovered some redundancies. The checker eliminated the manual labor of constructing those invariants by hand. Reading it again, we are really proud of this paper, and we are very happy to be honoured with this Test of Time Award. I think Alan's Cryptic system from 2001 is one of the very first static checkers of cryptographic properties of implementation code. I think today's use of refinement types for security protocols in the widely used security-oriented language F star can be traced back to ideas in this paper and first implemented in Cryptic. So the long version of the paper says that the two authors collaborated on this work, completed it partly at Microsoft Research in Cambridge and partly at DePaul University in Chicago. I loved staying in Chicago with Alan. He was incredibly hospitable to me, and it was always a mind-expanding experience. You know, on the one hand, he would be rebuilding the Linux kernel as we were busy thinking about a paper, and that was wow. On the other, there were always like conversations about sort of hot issues. I remember conversations about privacy, for example. It was such a pleasure collaborating with Alan. In Cambridge, Alan and I laughed so much while we were working that someone in an adjacent office actually went to complain to HR about it. I mean, our offices were actually above a nightclub in Cambridge, so you'd have thought that they'd be used to a wee bit of noise. So CSFW 14 took place in Cap Breton in Nova Scotia. You know, we were really so excited to be at CSFW for the first time, and we really thought we'd made it into the inner circle of security research. We are very excited to receive this award. Thank you again.